I think we'll start now. Dr. Oladele, I will introduce you. Good morning, colleagues, and thank you for joining this seminar. Let me just my camera on here for that you can see who I am. Okay, so Dr. Babatunde is my postdoc in the Department of Math, Science, and Technology Education. And as you can see, he is a statistician. And I've asked him to please conduct a seminar for us, especially in our department, because many of us are qualitative researchers, and we have very little or no experience or knowledge working with quantitative statistical analysis, and he has kindly agreed. Dr. Oladele, I've found, explains some complex stuff very, very clearly to me, so I thought it would be helpful to all of us here in our department, especially as we are under pressure now to integrate more and more mixed methods into our research. So without further ado, I'm going to hand you over to Dr. Babatunde Oladele. Over to you. Thank you.
Good morning. Thank you, sir. Good morning, everyone. First and foremost, I would like to thank God Almighty for this opportunity. I would also like to thank the head of Department of Mathematics, Science, and Technology Education, as well as Professor Mavuru, and also would like to appreciate my host, Dr. Rane, for this opportunity, giving me this platform to disseminate information to information on the item analysis. We as academics, we conduct research. As researchers, we conduct research. As students, we conduct research. And we usually develop instruments. Our instrument contains items which we use to collect data from our participants or respondents.
Sorry, Babatunde, I'm not sure why we can see, I don't know if it's just me. We are looking at your screen, we can't see the slides.
Okay. Okay, sir. All right, sir. Is it fine?
Yes, thanks.
Yeah. So we as researchers, we usually conduct research and we develop instruments which we use to collect data. And it is important for us to confirm if the instrument that we have developed, the items in the instrument, if they are good, acceptable, or are poor. And that is the essence of item analysis. So what is item analysis? So today, I am presenting a seminar titled Item Analysis Using SPSS. The statistical tool that will be used in the SPSS software is called Cronbach Alpha. Now, what is item analysis? Item analysis is a statistical procedure that is used to evaluate the quality of test items, that is, questions in our instrument or statements in an instrument such as questionnaire or test. Item analysis helps us to determine whether our item is clear or understandable. It helps us to know if the items in our instruments are consistent, and also measuring the overall construct. It helps us to know if the measurement we are doing, if it is meaningful or not. Item analysis is commonly used in education research, psychology testing, and survey design. Now, item analysis, for us to do our item analysis, there are different criteria, or let me say different features that we need to use to know if our item is of good quality. We have validity, reliability, usability. But the core of item analysis is reliability. Now, what is reliability? Reliability is a method that we use to measure our item, to know if our item measures what it's supposed to measure consistently, again and again, or repeatedly. It tells us about the stability of the instrument. Now, reliability of our instrument, we can say our instrument is reliable when it produces consistent results over time. That is, we have used our instrument and we use it again. We are having the same level of consistency. It helps us to know if our items or our instrument it measures the same construct, that is the underlying construct. I would like to show us what I'm trying to refer to as instruments. I hope we can see this is an instrument. This instrument is the name of the instrument, Teachers Instructional Strategy Scale. And this is a scale that is measuring the construct, teachers' instructional strategy. All these statements, all the items, they are put together to measure this construct. The construct is instructional strategy, teachers' instructional strategy. So the point I'm trying to make here is that reliability helps us to know if our item actually measure the construct. The construct I just showed us now is instructional strategy, teacher instructional strategy. In reliability, we have different types of measures that we can use to measure reliability. But the most common one is the Cronbach alpha, which measure internal consistency of our instruments. Now, what is Cronbach alpha? Cronbach alpha is a statistical index that measures how well a set of items measure a single unidimensional latent construct. The construct we are measuring with that instrument that I've shown up is instructional strategy. Now, how do we calculate the Cronbach alpha? The Cronbach alpha has a formula, and this formula is alpha equals to n all over n minus 1 into bracket 1 minus summation variance all over total text variance. At the point of doing reliability calculation, we need to know the number of items. We need to know the inter-rater correlation. We need to know the variance of the items. We need to know if our items' overall reliability coefficients are good, acceptable, or poor. In a nutshell, when we do our calculation or we do the computation, our item, when we have more item, we have high reliability. When we have high correlation, we have high reliability. But when our alpha, the index of alpha, if it's low, we have low consistency. Now, how do we interpret our Cronbach alpha index or coefficient? It ranges from 0 to 1. Whenever our reliability index is above 0.90, we say is excellent. If our instrument reliability is between 0.80 to 0.89, we say such an instrument is reliable. is good. When our alpha value is between 0.70 to 0.9, we say it is acceptable. When the reliability coefficient is between 0.60 to 0.69, we say it is questionable. When the reliability coefficient ranges from 0.05 to 0.59, we say it's poor. When the reliability coefficient is, less than 0.50, it is unacceptable. We have to note that having excellent reliability does not mean it is 100% good, but it can lead to redundancy. For example, redundancy in the sense that we are having a kind of items that are similar that we have for, I'm giving an example. Maybe the statement of the instrument says thus: I am satisfied with my job. I am happy with my job. If you look at these two items or statements, they are very similar. So it can cause redundancy and it can make our reliability coefficient to be more than 0.90. Now, what are the purpose of doing item analysis using Cronbach alpha? That is, what do we need to get for using Cronbach alpha? One, we want to determine the internal consistency of our items. We want to identify weak or problematic items. We want to improve the quality of our test or questionnaire. We also want to ensure validity support. The condition for validity of a test requires reliability. So it says that an item, when an item is valid, it is said to be reliable. Now, Cronbach alpha is the mostly used instrument which actually talk about internal consistency. And for us to use Cronbach alpha, there are assumptions. There are assumptions. We don't just go ahead and use Cronbach alpha to do our item analysis. We need to follow this assumption. Our items should be positively correlated. That is, all the items, all the statements. Let me show you the statement I'm talking about. You can see, if you look at these statements, they are all positive. The teacher solved classwork clearly. The teacher provides, let me zoom it so that we can see it better. The teacher solves classwork clearly and accurately. The teacher provides solution to the assignment. So you can see that all these statements, they are positive in nature. So the point here is that we should ensure that our items, they are all positive. If they are not positive, we recode them to positive, from negative to positive. That's the way we can do that. Then our data must be continuous or ordinal in scale. Like what we have here now. If you look at this instrument, this is in ordinal form, or let me say scale form, because we are rating. We have 5 for very large extent, 4 for large extent, 3 for some extent, 2 for small extent, and 1 for very small extent. So this our instrument is observing this assumption. Also, the sample size should be reasonably sufficient. That at least we should have participants, people that are going to respond to our instrument, to be a kind of sufficient, let's say from 100 and above. Now, there must be no missing data. In our data set, there should be no missing data. I will show us the data set soon. The data that we are having, all our items, must not be in dichotomous or binary form. That is, we should not make use of yes or no, true or false. We should have a kind of Likert format like we have in these instruments, like what we have here. There's another instrument that I'm showing us here. This is another one. This is another instrument that is measuring nature of workplace romance. So we have strongly agree, neutral, disagree, and strongly disagree. So this is not a dichotomous items. It's not, we are not having yes or no items in this. So without much time, we already have the assumption. So we need to look at our data sets and see if our data set follows or observe this assumption. It's very important, because if you don't observe these assumptions, your result may not be valid. Now, the next thing is to conduct item analysis in SPSS. So there is a procedure. So I'm going to show us a data that have been coded. These instruments have been given to respondents, and the respondents have actually responded to this instrument, teachers instructional strategy scale. So it's a scale. The students were asked to rate the teachers concerning their instructional strategy. So I will show us the data set now. This is the data set for so let's check our data set. You can see I want to open the data set up. You can all see the data set that the students have actually responded to the data set. Some have they've actually chose some extent, large extent, this and other. Now let's look at our data very well. The data have been coded. We need to confirm some things here. Now let's check the value, the response format. This is the response format. We can see that is in form of scale. The students need to rate the teacher's instructional strategy by clicking, maybe picking one, picking small extent, some extent, large extent, and very large extent. So this is well coded. Now, another thing that is important here, we need to look at this measure, this angle. We need to look at it very well. It needs to be in form of scale or ordinal, but this, what we are using is a scale. That's why we have it as scale measure here. It should not have nominal. There should not be nominal. So it's very important for us to check our instrument coding very well. Now, back to how do we conduct item analysis? How do we conduct item analysis using Cronbach Alpha? This is the software, SPSS 25. If you have SPSS 25, you'll be able to follow this teaching. Now, we want to do Cronbach Alpha. We have the data view. This is the variable view, and this is the data view. So the students, we have how many students here? Let me check. We have, I think, 148 respondents. They've responded to this. They've actually used it to assess their teachers' level of teaching strategy. And now we want to know if those items actually measuring teachers' instructional strategy or not, or if these items are good, they are acceptable, or if they are poor. Now, let's go to the analysis. We click on the menu, Analyze. There will be a drop down. Then we go and put our cursor on Scale. We move to where we have Reliability. The drop down, submenu. So we click on Reliability Analysis. Analyze, Scale, Reliability Analysis. So we click. And what we have here, this is what we are going to have. We are going to have this box. And in this box, to the left, we have the items listed there. The items listed 1, 2. There are 20 items in number. 20 items, or we say 20 statements in number, which we have designed to measure teacher instructional strategy. So we now move to what we need to do now is we can actually do Control A on our keyboard and move everything. The other way to do it is to click on Shift button and the arrow down to highlight and to move. We click on Statistics. Under Statistics, we have descriptive menu there. What we need to click here is item, scale, scale item deleted. Then on the other side, we have inter-rater of inter-item correlation. So we click on the correlation and click continue. Something is important that we need to note here. Look at the model. On which tool do we want this to run? It's already on alpha by default, but you need to take note of this and make sure you put it on alpha. So you make sure this is on alpha. Then we click OK. When we click OK, the analysis is already run. So we have this. We have all these results, the output. The very first output that we need to look at is this output that has to do with case processing summary. You know, in the assumption that we need to observe before doing item analysis, there must no missing data. So if you look at this place very well, we have 148 and nothing excluded. There is no missing data. So this case processing summary is telling us the number of respondents, and they are showing us, having us that this our data set is good to go, is fit for Cronbach alpha analysis. Now, the next thing is the reliability statistics. The reliability statistics is the core of Cronbach alpha. It is the core of Cronbach alpha, where we have the Cronbach alpha index or coefficient to be 0.838, which shows that this our item is, the items are good. They are good. They are even beyond being acceptable. Then we have the standardized Cronbach alpha, which has to do with the composition of the variance being put together in the items. So the number of items that we have here is 20. Now we'll move to the next table. The next table that we have, it will show us item statistics. Item statistics. In the item statistics, we have the mean. The mean. Now, it's very important for us to note that the mean should not be extremely low as 1 or extremely high as 5. So if you look at all the mean for the items one by one, there is no one that is 1, extremely 1, low as 1, or extremely high as 5. So this shows that the student or the respondent on the item, the score they give to the items are actually moderate. Then we have the standard deviation. The standard deviation is talking about the spread of the items. If you look at them very well, it ranges from 0.544 to 1.25, which shows a good spread of the items. Now we move to the other table. The next table here that we have is talking about inter-item correlation matrix. This matrix is actually giving us the result of the relationship between the way the items correlate, the way the item works together to measure the underlying constructs. Now, it is a rule that the figures here or the index here should not be less than 0.20, and it should be between 0.20 and 0.80. So if we have the value like that, it means our items actually correlate very well, they converge very well, and they're actually measuring the construct that we intend to measure them with. So if you look at, let's go under item 1. If you look at the values there, you will see that those values, all of them, there are many out of this, you can see so much, they are all having value that ranges between 0.20 and 0.8. If we have anyone that is less than 0.2, like this item 13 now, item 13, item 15, item 20, which is even negative, all these items, it means they are measuring more than one construct. And if you have any one that is higher than 0.8, it means there is a redundancy. It means some items are very similar. Now, the next table, which is very important, this table helps us to know if our item are to be rejected, are to be retained, or are to be revised. This table, item total statistic, usually give us a kind of meaning to it. No, so if we look at scale, the very first column there, we have scale mean item deleted. So for this, if you look at the mean value, they all ranges, their values are almost similar. There is no one that is extremely far from each other. 63.50. If you look at it, except item 20, which shows 64.90. So the mean here is also showing that this item is not discriminating well between the scorer, the participant. So we go to item, another table here is scale variance if item deleted. So we have this as the variance of the items. If you look at them very well, their range, the ranges are almost the same as well. We're having from point, let me see the least one. The least one is 40, I think 47.8, while the highest variance here, contributing variance here, is it 56. So you can see that this item 20 is need to be looked at. Also, we look at the next one is correlated item total correlation. Here, this value here, they are very important. They are very, very important because any value that is less than 0.3 is said to be a poor item. And any that is between 0.3 and 0.5, they are said to be good item. But by the time they are moving beyond 0.5, they are excellent, they are moving beyond excellent value. So the point here is that our item here, if you look at them very well, except item 20, that is not having a good correlation. So then we have another column here. This column is squared multiple correlation. This one is telling us about the predicted level. It's like the linear regression where we have R squared. That is telling us about how predictable are these items. That is their contribution in terms of the variance. So if you look at this, we have item, I think item 12 is the most predictable among those items. Now, if you go to the next one, it's Cronbach alpha item deleted. This one is showing that if you should delete any item, this is the Cronbach alpha that we are going to have. So the point here is that if you look at the value for item 20 is higher than that of the entire reliability. We have 0.877. Look at this. Let's look at this. We have 0.83. So it means this item here is problematic. So this item 20, we need to remove it so that we can have a perfect reliability items, that our items measure internal consistency. So without wasting much of our time, I want us to do a kind of, I want us to remove that item 20 to now see. Then the item 20, we can even see what is there. Let's even see what we have on the item 20. So you can see the item 20. It's saying that teacher ensures students get notes. So teachers ensure students get notes. So they didn't know how to, maybe the students did not know how to score the teacher or whatever. So I think that is why the items is giving us, the way the item is worded, I mean, it's written maybe a problem to the respondent. So I want us to remove that item while we go to the next analysis of Cronbach alpha for another instrument. So let's go back and do analyze, scale, reliability. Then we are removing item 20 to see if there will be a change to our Cronbach alpha index. So let's remove item 20. So we already removed item 20, and we are running our Cronbach alpha. Now, we have run our Cronbach alpha. We have our Cronbach alpha now. You can see that the Cronbach alpha has increased to 0.877, to 0.877, showing that this our item, our items, they are correlating very well. They are measuring the construct they are supposed to measure, and there is no redundancy among the items. So if you come down and see, if you look at this angle here, and where we have the column that has correlated item total correlation, there is no one that is less than 0.3. Looking at them, there is no one among them that is less than 0.3. So also, if you come to the alpha item deleted, there is no item, no coefficient here that is higher than that of the overall Cronbach alpha. So it means we have a valid instrument now. This our instrument is perfect. It's a perfect instrument that we can use to measure teacher instructional strategy. Now, the second example is looking at the second instrument. Let's look at the second instrument. Let's look at the second instrument and do Cronbach alpha on the second instrument. The second instrument, like I said earlier on, is measuring the nature of workplace romance. And we have close to 17 items. This one is an ordinal, on ordinal scale, because we have strongly agreed. So the data set as well, let's check the data set as well. So this is the data set. So if you go and check the variable view, we have this. We have is on scale. So we need, you can see the way it's done, strongly agree, disagree, neutral, and what have you. So here we need to change this to ordinal, because this is ordinal, because the students are they are responding based on ordinal. So we need to move everything here to ordinal, because it's not a scale. A scale is when you are rating, but here we are not rating. We are only agreeing to the statement to say workplace romance do occur in our place of work. Now, I'm trying to move everything here to ordinal, because it should be in ordinal measure. So I'm almost done. I'm almost done. Now, I want to use this instrument as well. I want us to analyze this instrument as well to be able to see the difference between the two instruments. So I go ahead and click on Analyze, Scale, Reliability. So when I click on Reliability, the item they already moved there. So I can reset and try and Control A, then move it to Items, the Statistics. I click on Item, Scale, and also Correlation. So I go to Continue. I make sure that the model is alpha. Then I click on OK. So when I click on OK, the analysis is already there. So I go and check the analysis. So for this instrument, the Cronbach alpha is 0.489. 0.489. 0.489 is said to be poor. If we should go by this, can we all see it? It's said to be unacceptable, because it's less than 0.50. So it means the items there in that instrument, they are not actually measuring. We need to do some work on them. Let's check. Now, look at this place. Look at this mean. The mean value here. Let's see this mean value. We can see we have item 7. Item 7 to be low as 1. We don't have anyone that is extreme as high as 5. So this is telling us a lot of things concerning this instrument. Now, let's check here too, the correlation matrix. The correlation matrix, if you look at it very well, the value that we have, you're having negative values. And we're having values that are even less than 0.2, which shows that some of these items, they are measuring more than one construct. And I don't think we have above 0.80, no. we don't have. But it's showing that this instrument or these items, they will be measuring more than the required unidimensional latent construct. That is one construct, which is the construct here measuring is workplace romance. So if you look at this item very well, let's go to where we have correlated item. We are looking for 0.3 and above. So if you look at this item 5, it's negative. Item 7, negative. And item 10, negative. Item 12, negative. If you look at their Cronbach alpha, their Cronbach alpha value is higher. Like, let's look at this item 5. The Cronbach alpha value is 0.54. It's even higher than the overall Cronbach alpha of 0.48. So this instrument is problematic. So we need to fix some of these instruments. How do we do it? Is either we revise those instruments or we remove from them and we have those ones that can actually be reliable. Now, I want us to point out those ones that we need to remove so that we can have, let's see, we are removing item 5, item 6, item 10, item 12, item 17. So let's remove them and see what will happen to our Cronbach alpha. Now let's remove them and see what would our overall Cronbach alpha. We are going there. So now the item we are removing is 5. We are removing item 6. We are removing item 10. We are removing item 12. We are removing item 17. Item 17. So we just remove item 17. So we remove item 5, 6, 10, and 12. We still need to check if there are other items that we are supposed to remove that we have not removed. Let's check properly. So we have said we are removing item 5, which is negative 0.32. We are removing item 6, which is 0.007. Item 7 is not there. We are supposed to remove item 7 as well. So let's remove item 7 as well. So we are removing item 7. So we have 17 items and we have removed 6. So we have 11 items. Let's see these 11 items, if they can actually measure the construct that we want to measure. The construct that we want to measure is nature of workplace romance. So we go ahead and click. Let's check if we are still having this checked. Oh yeah, yes, they are checked. So click OK. By the time we click OK, we see what we have. Now, can we see what we have now? The reliability has increased from what we have before. This is what we have before, 0.89. We have removed the problematic items. Now we are now having 0.84, which shows us that now these 11 items, they can actually measure workplace romance. So our item now, the instrument now is now reliable, is acceptable, is good. You can go ahead and use this instrument, these items, to measure nature of workplace romance. Now, if you look at it very well, it has come to the level of good reliability. Now,
okay,
the point, the point now, I still want to give us some explanation concerning Cronbach alpha. That is, we have talked about the decision rule, which says that item correlation must be more than 0.3, which we have used. Anyone that is less than 0.3 should be removed or revised. So those items that we removed, we can actually revise them. I can remember item 5. Let me just check. Show us item 5. This is item 5. Item 5, where is it? Okay, item 5. We remove 5 and 6. Workplace romance among university employees could turn into serious, committed, and relationship or even marriage. So you can see the word of the item. So we can actually try and revise this. Workplace romance could start during the process of carrying out tasks together in our institution. So the point here is that This item, we've removed them already, but there's a way we can revise them and they will now be meaningful. Now, there was a point I need to make before earlier on that I did not make. The point is that before we do item analysis, there must have been pilot testing of our instrument. We need to pilot test our instrument before we do item analysis using Cronbach Alpha. Now, advantages of Cronbach Alpha is easy to compute, is widely accepted, and is suitable for Likert scale. Limitation, it has its own limitation because it's only using Cronbach Alpha, we are only measuring one construct. It is unidimensional. A single construct can be measured using Cronbach Alpha. When it's dimensional, we go for higher item analysis too, like factor analysis. Then it is sensitive to number of items. Does not measure validity. Yes, reliability of item using Cronbach Alpha does not measure validity, but it's a condition to validity of a test. Now, high alpha does not mean that our scale is good. No. If we have alpha value like 0.95, it does not mean that our scale is good. But if we have between 0.7 and 0.8, our scale is very good. Another important note before is that when we have lower internal consistency, it does not mean that our item, it means our item, they are not correlating very well. That's why we are having low, like that of the nature of work, the data that we use. We have low internal consistency with that one. Then poor item quality. Some question may be confusing, like the one I just read to us, or irrelevant, or not aligned with the construct you are trying to measure. Too few items can also affect the reliability. Multidimensionality. If our items are measuring more than one construct, it can also affect the sample as well. Our sample should be from, let's say, 30 and above. Our sample should not be less than 30. Like we have the sample size here. If your sample is between 20 and 30, it might bring about reliability estimate less trustworthy. Then when it is moderate, between 50 and 100, it can be acceptable and maybe fluctuating depending on the item. Then when our sample is large, we can have a stable, precise, and generalizable reliability coefficient. Now, the threshold is this, that you need to have 100 respondents. That is the threshold, or let's say the rule of thumb. So he's saying that if you have 10 items, the people that the respondent should not be less than 100 participants. So for the item as well, the ideal number of items is, for the short scale, 3 to 5, for moderate scale, 8 to 12, for long scale, 15 to 20. And the rule of thumb is that we should have at least between 6 to 10 items per construct. If you are measuring any construct, your item should not be less than 6. It should be between 6 and 10. Now, not only Cronbach Alpha can be used for item analysis, we have other tools that we can use, like the item difficulty index, which talks about the proportion of people responded getting it right correctly, talking about how difficult and how easy the item are. Then the item discrimination, talking about the difference between the higher achiever and the lower achiever. Then point by area is also can be used in terms of correlation, the relation between the item, the way the items are performing. Then could and Richardson also can be used where we have dichotomous data, like true or false, yes or no. We can actually use this to do the reliability calculation. Then could Richardson 21 is also assuming that we have equal difficulty. Split half reliability can also be used. Test reset can also be used. Factor analysis, like I said earlier, can also be used, which measure beyond. When your item is measuring more than one construct, you need to use factor analysis to do the item analysis. Then item response theory too can also be used to evaluate the item characteristics in terms of difficulty, discrimination, and guessing. Then we have Rash model as well, which can also be used. This one is talking about the item fit. The item fit and the measure both difficulty and respondents of our ability. Now, a recap before we end the seminar. The recap is this. Item analysis. we have what we call item total correlation, which has to do with how well each of our items correlates. We also have alpha index, which talks about impact on reliability if an item is moved. Then we need to revise weak item or we need to remove them. It depends. Then problematic items too, they need to be identified. They need to be spotted and we need to identify them. And if possible, we jettison them or we revise them. Then low correlation at times, negative correlation at times. Our items, poor items can bring low correlation or negative correlation and even low reliability. Now, how do we improve our reliability? Steps to do this are we need to revise or remove the items. We need to add more items in case our items is not enough or they are not enough. And also check the dimensionality of our item. If they actually measure what they are supposed to measure, if they're actually measuring, they are converging, they are correlating well, they are contributing the variance well so that they can measure what they are supposed to measure. So that's all about item analysis using Cronbach alpha. So there is a suggestion. We need to create 5 Likert scale question, enter into data spaces, compute our Cronbach alpha, identify weak items, and report our findings. I need to appreciate the head of department and our team for this opportunity, and also thank this audience for listening to this seminar. Thank you so much.
Thank you very much, Dr. Oludele, for the presentation. We have slightly more than 10 minutes for questions and answers or anything from the colleagues who have joined us. All right. Okay, so we have the first question. Go ahead.
Okay. Colleagues, good morning. My name is Dr. Akobi Thomas. Thank you so much for this wonderful presentation. I have a question which concerns missing item. Missing item is one of the assumptions to mention in running Cronbach alpha.
Yes.
So now, if I understand what missing item means, that you are coding a particular questionnaire and maybe you have like the first a scale you used, 1 to 20 items, and a particular respondent or a particular student did not tick item 10. And then you are coding and you discover that item 10 is blank. So if you code without it, that constitutes a missing item. So as a researcher, what do? You begin to tick those ones that the students left. Maybe they left it to come back to it later, but they forgot. As you are coding, those ones they forgot to tick, or maybe they don't know the answer, they don't know what to do, they left it blank. What do you do to overcome the missing item problem? Thank you.
Thank you, sir. Thank you, sir, for that question. Yes, we can solve that. There are methods of handling missing data. So we should not leave our data sets with missing data. We need to fill it. There are methods or ways of handling missing data. So that it must be fixed. We should not allow our data to have missing data. Thank you.
Okay, thank you. I don't know if Dr. Akobi, if your question has been answered. Do you want to know how?
I wanted to know how, but he said there's a way, and I don't know the way. So I don't know. My question is not answered in a way.
Thank you, sir. There are methods. We have mean method. We have regression method. We have multi-input method. So there are methods that we can use to fix the mixing data. There are methods that we can use. We have the mean method, whereby we look for the mean of all the respondents and use it to fill that missing data. So there are methods that we can use to fix missing data. Thank you.
Okay, so please just to understand it very well, do you do this at the point of coding, or you finish the coding first and allow the missing data to be, and then you run the analysis and check them in before you go back and fill?
Yes, sir. Thank you, sir. You can only know the missing data after you have coded. You have coded your data. That's where you know if you have missing data. There is a way you can do that by running frequency of the data. Like, let me just show you now. You can go to analyze, descriptive, and come to frequency. So if there are missing data, it will show. Let me do it this way. Let me just remove this. I'm removing this code here. And I want to run it now. You see, it's going to show a missing data. Oh, yeah. So I'm running descriptive. Is it? Sorry. Frequency, descriptive. It will run indefinitely. So let's see. So you can see. Where is it? You can see missing here. Missing. So it's showing there's a missing data here. It's showing there's a missing data here. So we know item 7 has a missing data. So, and there are methods, like I said, that we can use to fix the missing data. Look at this place. Under SPSS, under analyze, missing value analysis, multiple imputation. You can come here and use methods to actually fix the missing data. Thank you.
All right, thank you for that. Then we have Dr. Salami. Dr. Salami, you have a question?
Yes. Thank you very much.
Please ask your question.
Yes, thank you very much, Doc. Thank you, Dr. Oladele, for this comprehensive and well-explained seminar on item analysis using SPSS statistics. I have just 2 questions. The first one is, can Cronbach's alpha be used for dichotomous items? Yes or no question, then you kindly explain. Also, we see that pilot testing plays a very important role before conducting item analysis, because it helps researchers evaluate the quality and effectiveness of an instrument before the main study. Now, my question is this: what then is the role of pilot testing before conducting item analysis? Thank you.
Thank you very much, Dr. Salami, for your question. The very first one is, can we use Cronbach alpha for dichotomous data? I will say no. It cannot be used. And that is the essence of using Coulthard-Richardson. We have Coulthard-Richardson method of reliability, which is most suitable for dichotomous data, like yes or no, true or false data. Though some school of thought says that when Cronbach alpha is used to run it, it will still give you results. It will give you results, but the best tool to use is Coulthard-Richardson method of reliability. Then your second question, pilot testing. Pilot testing is very, very important. And you can't do item analysis without doing pilot testing. You must have been trial testing or pilot testing before we do item analysis. So it's important for us to first go ahead and administer our data, our instrument. The item analysis is majorly meant for pilot testing data that have been collected. So we want to know, the reason for pilot testing is to be able to evaluate our instrument and to be able to know if our instrument is good or not. Thank you.
Thank you very much. I'm satisfied.
Dr. Adamu, I think Dr. Adamu also has a question.
Yeah. I want to, greetings, colleagues. I want to appreciate Dr. Ladele for that insightful presentation. In addition to the response you provided to Dr. Is it Ogbe? Yeah, the doctor that previously asked a question on missing data. Yeah, I want to add to what you have correctly said. There's a way I treat missing data. You see, out of all the methods you mentioned, which are very much correct, I use the list-wise deletion method. Yes. And what do I do? What do I do there? If, for example, I administered an instrument on 200 respondents. While entering the data, if I discovered that only 192 respondents correctly filled my questionnaire, then I discovered that out of the now eight could not fill the items correctly. Those 8 for each of the items in each of the questionnaire, making 8 respondents in that questionnaire, I treat them as missing data. And what do? I delete them, list-wise deletion. I don't include them in my data set. I delete them and make use of 192. Then I go back to my methodology to report that 200 copies of questionnaire were administered on 200 respondents. Only 192 were returned with the items completely filled. As a result, these 192 were only used in the data set and analyzed. That is how I treat mine. People have different ways, methods, like you rightly mentioned, of treating theirs. I do that and I report it clearly in the methodology.
Yeah. Yes.
You're welcome. Then I want to add something. As a test developer, I am a scale developer anyways. I've come to realize, I was thinking that in this kind of seminar, we would have a good number of PhD students in attendance, but unfortunately, I'm looking at the attendance here. I can't see a quite number of them because most times when they turn in their questionnaire for vetting or validation, you begin to see so many errors. So that is why I said this seminar is really very important to them. But unfortunately, the majority of them are not here. So I think another seminar is supposed to come up. Thank you, Dr. Mavuru, for organizing this seminar. And thank you, Dr. Ladile. I really appreciate it. But I think something is missing. Our students need to be taught how to develop skill. They really need to have that knowledge on how a skill can be developed and how to pull these items together from the number of constructs that they have in their research topics. Thank you so much. I really appreciate this opportunity.
Thank you, Dr. Adamu, for your wonderful contribution. Okay. Thank you so much.
We have time for one last question. Dr. Akobi again.
Okay, Prof, thank you. My own is not really a question, but I just want to clarify something that I read before and I know that has been working. The presenter said you cannot use Cronbach alpha for dichotomous item like yes and no. And he said you can only use Kuda-Richardson, like the KR20 or KR21, depending on the variance of your item. But I want to say that Kuda-Richardson is only used, that's from my knowledge, when your items have preferred answer, like the achievement test. If I say 1 + 1, obviously the answer is 2. And so and if the answer is 2, maybe A is 2. So every child must select 2. If you don't select 2, you are wrong. And so when you have a preferred answer, that is when you can now use the Richardson. But in the case of yes and no, there are some scales that you develop. The yes may be correct and the no may be correct depending on the situation of the respondent. So in this case, what do we do? Because here, the yes is also correct, the no is also correct. And then you say, you cannot use Kuda Richardson in that type of scale. So in this case, I'm confused.
Yes, thank you, sir. Sir, I said it earlier on that some school of thought says that what Kuda Richardson will run, the output of Kuda Richardson for dichotomous data, Cronbach Alpha 2 will also run it. But there could be a slight difference between the coefficients. Like if you use Cronbach Alpha to run yes or no, you see, the yes or no, true or false, they are dichotomous data. They are not polytomous. And KL20, like you said, is used for when we have right answer. Yes. It's also used when we have dichotomous data. So yes and no is a dichotomous data. So the point here is that we can use Kuda Richardson to run yes or no. Also use Cronbach Alpha. You cannot compare the output. You are going to see that there will be a difference between the output. And that could be, it could make another meaning. Let's say, for instance, that of the Kuda Richardson is giving us 0.0.71. The Cronbach Alpha may give us 0.69 or give us something higher, telling us that this thing is acceptable or a good, reliable instrument, or we say a reliable instrument, that the reliability of the instrument is good. So on that note, I think we have to take caution, because dichotomous data, Kuda Richardson is best fit for dichotomous data. Thank you.
Okay, thank you for that, for those questions, and thank you for the responses, Dr. Oladele. Colleagues, I think our time is up, so the meeting has to close. So if you want to speak with Dr. Oladele afterwards, you are welcome to communicate with him. Dr. Oladele, I don't know how people are going to communicate with you, but they can always email me, and then I can pass on your contact details to him. Otherwise, he is available. He does come to our department regularly, so you can always communicate with me to pass on the message to him if needs be. But thank you, Dr. Oladele, for the presentation. It was well received, and I'm sure it has answered a lot of questions for the audience. I know for a fact that there are a lot of PhD students here, master's students over here, so I'm sure they found it very valuable. And of course, this is just the beginning. So you've only dealt with one aspect of statistical analysis, and it was more of a beginner course for the qualitative researchers that are here. So we appreciate that. Thank you, colleagues, for attending. And if you require any more assistance or any more consultations or advice from Dr. Oladele, you're welcome to communicate with me, and I will get him in contact with you. Thank you so much, and have a nice day.
Thank you, sir. Thank you, everyone. Thank you. I appreciate it.